Deep in the constellation of Virgo, 2,000 light-years from Earth, sits a dead star spinning faster than a kitchen blender. This is PSR B1257+12, a superdense neutron star known colloquially as Lich. It rotates on its axis 365 times every single second, sweeping intense beams of lethal radiation across the cosmos like a hyperactive lighthouse. For decades, astronomers believed that the violent birth of such an object would instantly vaporize any nearby worlds. Yet, orbiting this cosmic dynamo in the absolute dark of space are three ancient, frozen planets. They were the very first exoplanets ever discovered, surviving in a graveyard where life should be entirely impossible. The discovery of this bizarre system in 1992 shattered our understanding of how planetary systems form. Polish astronomer Alexander Wolszczyn was utilizing the massive, now collapsed Arecibo Observatory in Puerto Rico to study pulsars. Pulsars are the collapsed cores of massive stars that went supernova, packed so tightly that a single teaspoon of their material would weigh about 1 billion tons on Earth. Wolszczyn noticed minuscule, periodic irregularities in the arrival times of the radio pulses from PSR B1257+12. These pulses are normally so incredibly precise that they can keep time better than atomic clocks. The only logical explanation for these sub-millisecond delays was the gravitational tug of orbiting bodies. By analyzing these tiny variations, Wolszczyn and Canadian astronomer Dale Frail confirmed the existence of three distinct planets, later named Drog, Poltergeist, and Phobter. Located roughly 12 quadrillion miles away from our solar system, this discovery proved that planets could exist outside our solar system, but they were nothing like what scientists had anticipated. Instead of orbiting a warm, life-giving star like our Sun, these worlds were trapped in the perpetual, cold grip of a stellar corpse. To understand the extreme environment of PSR B1257+12, one must look at the physical reality of these planets. The innermost world, Drog, is extremely light, possessing only about 2% of the mass of Earth, making it barely larger than our Moon. It orbits the pulsar at a distance of 19 million miles, completing a single revolution every 25 days. The two outer planets, Poltergeist and Phobter, are super-Earths, each boasting roughly 4 times the mass of our home planet. If you stood on the surface of Poltergeist, you would experience a gravitational pull significantly stronger than Earth's, heavy enough to make every step feel like an exhausting struggle. But gravity would be the least of your concerns. The environment here is defined by relentless, invisible violence. The pulsar's magnetic field is 1 trillion times stronger than Earth's, accelerating charged particles to near the speed of light. These particles rain down upon the planets constantly, bathing their surfaces in a ceaseless torrent of high-energy X-rays and gamma radiation. This intense bombardment would instantly strip away any traditional atmosphere, leaving the rocky surfaces completely exposed. Yet, this radiation also creates a hauntingly beautiful phenomenon. As the high-energy particles collide with the rocky crusts, they trigger brilliant, global auroras. Instead of the gentle green curtains of light we see on Earth, these alien auroras glow with an intense, eerie violet and blue hue, painting the perpetually dark skies of these dead worlds in colors of radioactive fire. The temperature on these planets is estimated to be far below freezing, likely plunging to -100 degrees Celsius, yet they are constantly bombarded by energetic winds hot enough to ionize atomic matter. The outermost planet, Phobter, lies about 43 million miles from the pulsar, taking 98 days to complete its orbit. If your body were exposed to this environment, the radiation would rewrite your cellular structure in seconds. The magnetic field of PSR B1257+12 channels electrons along its axis at nearly 186,000 miles per second. These particles slam into the planetary surfaces with enough force to slowly vaporize rock over geological timescales. Despite this utter desolation, some scientists believe that the gravitational squeezing of the planets could generate internal tidal heating, melting subsurface ice into underground oceans shielded from the lethal space weather above. How these planets came to exist around a pulsar remains one of the most profound mysteries in modern astrophysics. When a massive star runs out of fuel, it collapses and explodes in a supernova, releasing more energy in a few weeks than our Sun will emit over its entire 10 billion-year lifetime. Any pre-existing planets orbiting the progenitor star should have been instantly incinerated, or thrown violently into deep space as the star lost its gravitational hold. This means Drog, Poltergeist, and Phobter are likely second-generation worlds. They could not have formed when the original star was alive. Instead, scientists theorize they arose from the ashes of the destruction. Perhaps a companion star was slowly devoured by the newly formed pulsar, leaving behind a disk of debris that eventually coalesced into new planets. Alternatively, the supernova itself might have pushed material backward, forming a fallback disk of heavy elements that slowly clumped together over millions of years. Understanding which of these scenarios is correct is vital, because it tells us whether planet formation is an inevitable consequence of cosmic chemistry, occurring even in the wake of the most destructive events in the universe. The planets of PSR B1257+12 serve as a stark reminder of the universe's ultimate resilience. Everything you have ever seen, from the oceans of Earth to the familiar warmth of our Sun, is just one possible outcome of cosmic evolution. In the cold, irradiated silence of the Lich system, gravity has managed to craft worlds out of pure devastation. They spin in the dark, illuminated only by the ghostly glow of a dead star's lighthouse beam, proving that even in the absolute graveyard of the cosmos, the building blocks of worlds can rise from the ashes.